Ladies and gentlemen, boys and girls, children of all ages, this is Mr. Friel. Today's lesson is on scientific notation. Your essential question is, how can we write really large numbers without needing to continue adding zeros? Maybe you already know this. Have you seen something that looks like this before? 6.174 times 10 to the ninth? Well, if you need to pause it and think, go ahead. But I'm going to show you the answer in 3, 2, 1. That would be 6,174,000,000. That's called the standard form when you do write all the zeros. This is the approximate human population on Earth, I think from a couple of years ago. So there's a lot of people out there. At the end of this lesson, Spartans will be able to, I'm going to call him Sparty the Spartan. You are much more charming and cool, but you will be able to, number one, understand how to convert from standard form to scientific notation. 2, you'll understand how to convert from scientific notation to standard form. And 3, you'll understand how to convert numbers from words to standard form or scientific notation. The two most important are 1 and 2. That's why they're numbered 1 and 2. Number 3, you may see somewhere you have a word problem and it asks you to do that. Common mistakes. The most common mistake kids do when they do scientific notation is they say, well, I counted the zeros and that's my exponent. Not always true. That is only true when you start with a non-decimal number like 50 that has 1 0, the exponent will be 1. But most cases that's not true, or in many cases it's not true. Number 2, I can have multiple decimal points. I've seen many papers in my day where there's a couple decimal points. All numbers that we'll deal with have only 1 decimal point in the answer. Some helpful hints. Focus on the decimal point. It's not how many zeros there are, it's how far the decimal point moves. If you start with an integer like 7, write it as 7.0, which is the same amount. It just has a decimal point. Number 3, we've told you to stop using the letter X for multiplying. However, it's common for scientific notation to still use the X for multiplying. Sorry, we know that's confusing, but we want you to know that sometimes you will still see that X. Just don't use it in algebra for multiplying. Here's a little vocab section. Now, if you're watching the video, you need to pause it and match these up. If you're doing the activity in class, each of the answers in black font are answers, and the words up here match them. So if you want to take a second and do that, I will pause, and then I will tell you in 3, 2, 1. To change from one form to another, a word for that is convert. So if you see convert, it means to change from maybe scientific to standard form. The typical way we write numbers is, standard form. So that's just any number. You know, if you write 20, 30, 26, any number that you're used to writing, that's standard form. Where a number is related to the decimal, that's the place value. The number to the left of the decimal is the ones place. Then you have the tens place, the hundreds place. You guys remember that. On the right side of the decimal, you have the tenths, the hundredths, the thousandths. So place value is very important when you're talking about scientific notation. Finally, scientific notation. A way to write large or small numbers using the power of 10 and exponents. Okay, this is where we're going to start taking your notes, so you might want to pause the video here for people to be able to catch up on these notes. The first question is, what does scientific notation look like? This first example is pretty simple. It's just the number 5 being multiplied by 10 4 times. So that really means 5 times 10 times 10 times 10 times 10. So this is an easier way to write that. The ones that we'll be doing mostly have a decimal involved in them, so you're going to put the decimal point always between the first two numbers. You can only have one number to the left of that decimal. You can have a few to the right of it. You may see an X used for multiply. You probably will. You could see a dot, or you could also see the caret used for the exponent if the number isn't small like this. If the first number is not a single digit, like it was up here, like 1 through 9, then the decimal must be written between the first two numbers. There can only be one decimal and only one number to the left of it. I think I said that a couple times. Pause here if you need to catch up on these notes. Okay, some questions and some practice. If I have some blue font here, you don't have to copy that text. This is E1, means the first example. How do I convert from standard form to scientific notation? Well, 70 is a standard number, so I'm going to write it as 70.0 so I get the decimal down. I decide how far I need to move the decimal. Well, let's see here. I have to get the decimal to move over one place because I have to have it between the first two numbers. So I move it over that one place. Step 3, the number of places you move the decimal will match the exponent. So in my answer down here, you'll see my exponent is a 1. I moved it one place. We're going to have powers of 10, so you take that 7.0 and you multiply it by 10, and you do that once, you will get 70. This is kind of a ridiculous example because 70 is not really, there's no need to write it in scientific notation. It's not a large number. It is the number of points I will score on you if you try to play me in basketball. So bring it. Next, this one's a little more complicated. I probably should have put a screen on here maybe. Oop. Should have done that ahead of time. Sorry. Write 3 million in scientific notation. Maybe you already know how to do that. So if you want to pause and give that a shot, go for it. And in 3, 2, 1, I will show you the steps. Step 1. Oh, there it is. Add that 0.0 to the end. These are the same amounts, but you need to know where that decimal starts. Okay, how far do we need to move it? Well, it's here. We got to move it between the first two numbers. So you're going to move it 6 places. 1, 2, 3, 4, 5, 6. It's going to go where that comma is, right there. And that means your exponent's going to be 6. Right there. So you have 3.0 times 10 to the 6th. Why 10? Well, 10 is the power that moves a decimal one place value. That's why we multiply by 10. Nothing else on that page. Okay. We're almost done here. Example number 3. Write this number. Oh, Mr. Frio, come on. Okay. Write 3,260,000 in scientific notation. It's pretty similar to the last one, but there's this is where a lot of people mess up. A lot of people see these 4 zeros. Oh, again, pause if you want to try this first. You see these 4 zeros and you think, oh, the exponent's 4, and you would be wrong. It's not how many zeros, it's how far the decimal moves. So let's see here. We put the decimal in. How far do we need to move it to get there? Well, we have to move it 6 places, just like the last one. So it's going to be 3.26 times 10 to the 6th power. Notice there's only 4 zeros up here in the original number, but the exponent is 6. Also, you always need to write the non-zero numbers. So you'll see here 2 and 6 are still written, but after them it's all zeros, so that's when we cut it off. All right. Okay. I need to have a screen here. Wow. Well, I am still getting new at this, so be a little patient. How do I change from scientific notation to standard form? I'm going to pause the video here, and I'm going to make that a separate video clip, and you'll probably watch that next.